In this video, I'll be going over adding and subtracting polynomials. But before we get started, we need to make sure that we understand the standard form of the polynomial and that the terms are written in descending order. So the by degree. So degree, thinking about like here, what's in blue, that is like our exponent. So in this case, the degree of our polynomial is 3. And then notice how the degree or exponent of each of our variables is decreasing. So it's in descending order. So going from 3 to 1 and then last to that negative 17, which has a degree of 0. In this case, too, our leading coefficient is always with the first term. So we have coefficients here, but the leading coefficient is 5. So keep that in mind when we're writing our problems and writing our final answer in that standard form. With this first example, we're going to be adding and subtracting. Notice how in this example, the first one, we are just adding. And when you're adding, you are again just combining like terms. So a variable, but also that exponent has to be the same. So with 1a, notice how it's not necessarily in standard form yet. So this is 2x to the third power minus x plus 9. Then we're adding to that. I'll write my second polynomial here in standard form. So x cubed plus 5x squared plus 7x plus 4. Now combine like terms. So here we have x cubed, so 2x cubed plus 1x cubed. Now we have 3x cubed. Now, notice how we have x squared here, but no other x squared term to combine with. So we just bring it down. So 5x squared. Now we do have x. We have a negative x here, right? Negative 1x plus 7x. So negative 1 plus 7 is positive 6. So plus 6x. And then last, our constant. So 9 plus 4, which is 13. So notice how, again, writing our answer in standard form and just combining like terms. Now 1b, notice we are subtracting. So we do have that negative, or if you were to think about it like a negative 1. So just like when we were combining our complex numbers, we need to make sure to first distribute that negative 1 to every term. So I'm going to go ahead and also rewrite it so it's in standard form. So our first polynomial here, or binomial actually, that is a negative 2x squared plus 3. So keep the sign with the term. Then I'm going to go ahead and distribute. So now we have, instead of positive x squared here, negative x squared. Then I'm going to go ahead and write this next because we're going to go this term here because we're going in standard form. So not minus x anymore because we're distributing the negative. So now plus x. Then instead of plus 6, now minus 6. Now combining our like terms here. I have negative 2x squared minus another x squared. So remember, that's a negative 1. Negative 2 minus 1, negative 3. So negative 3x squared. Then we only have the one x term here, no other x. So just bring down plus x. Then our constants. We have 3 minus 6, which is negative 3. So there's your final answer. Go ahead and pause the video here and try combining these two example problems on your own, and let's see what you get. Let's go ahead and go over these two problems. So with the first one, 1C, both are actually in standard form, the binomial and the trinomial. They're both in standard form. So I'm just going to go ahead. I notice that I'm adding, we are adding, so we can just go ahead and combine our like terms here. So here, notice how there's just the x cubed. So I'm just going to bring down 4x cubed. That's positive x cubed. But we do have x squared minus 5x squared. So we have that 1x squared, but minus 5x squared. So that's negative 4x squared. We have no x term, but we do have negative 6 minus 1, which is negative 7. Now here again, they are in standard form, but notice how we are subtracting. So you do have to distribute that negative. So I'm going to go ahead and rewrite this. So we have 9x to the fourth plus 12x squared minus 7, then minus 3x squared, but don't forget not just minus 10, right, but plus 10. Now combine our like terms. There's no other x to the fourth power, so 9x to the fourth power. Here I have my 12x squared minus 3x squared, so now 9x squared. And then we have our two constants. I have negative 7 plus 10, making that positive 3. So here with these examples, we are introducing function notation. So function notation is just showing how here, for example, f of x is equal to this trinomial here, and g of x is equal to this trinomial here. Now I'm going to go ahead and write our g of x trinomial in standard form. So this is 16x cubed plus 6x squared minus 5. So I just went ahead and rewrote that in standard form because our first f of x function is already in standard form. Then notice we are adding in the first problem. We're adding f of x plus g of x. Well, again, what is f of x? F of x is negative 36x squared plus 6x minus 11. And then we're adding to that g of x. Well, what's g of x? 16x cubed plus 6x squared minus 5. So now we can just combine our like terms. Notice how there's no other x cubed term, so I'm just going to bring that down. 16x cubed. We do have 2x squared. I have negative 36x squared plus 6x squared. So that's now going to give me negative 30x squared. There's no other x term, so I'm going to bring down plus 6x. And then last we have our constants. So we have here negative 11 and negative 5. Negative 11 plus negative 5, negative 16. So notice how you're still combining the polynomials. You're just using the function notation. So notice how here we have f of x, but now we are subtracting. So I'll go ahead and write out. So f of x again is negative 36x squared plus 6x minus 11. Then minus our g of x, which is 16x cubed plus 6x squared minus 5. Now I'm going to go ahead and make sure to distribute the negative 1. So I'm going to rewrite this now again as bringing down our first. So negative 36x squared plus 6x minus 11. Now 16x cubed minus 16x cubed plus 6x squared is now minus 6x squared. Minus 5 is now plus 5. Now we can combine again our like terms. Now notice we have a negative 16x cubed. So I'm going to bring that down because there were no other x cubed terms to combine with. Now I've got my negative 36x squared, but minus 6x squared. So that's negative 36 minus 6, giving you negative 42x squared. There is no other x term, so plus 6x. And then last we have our constant. So I've got negative 11, but now plus 5, which gives you negative 6. So go ahead and pause the video and try these 3 U-tries. So we're using f of x, g of x, and h of x to solve these 3 problems, and let's see what you get. Now let's see how you did. So for the first one, we are adding f of x plus h of x. So f of x, which is, I'm going to rewrite this in standard form. So this is 5x cubed plus 6x squared plus 12. Then we are adding to that h of x. And h of x here is negative 8x cubed minus 12x plus 7. Now combining your like terms. I do have 2x cubed, so 5x cubed minus 8x cubed, negative 3x cubed. Then next, we have only one x squared, so plus 6x squared. Next, there is only the one x term here, so negative 12x. But we do need to combine our constants, so 12 plus 7, which is 19. Now, number 2, you are subtracting. So we are subtracting g of x, which here is 15x squared plus 3x minus 2. Then minus, right? So keep in mind we're subtracting h of x, which here again is negative 8x cubed minus 12x plus 7. So now I'm going to make sure to distribute that negative or negative 1 here, right, to every term. This then becomes 15x squared plus 3x minus 2, but now instead of negative 8x cubed, positive, so plus 8x cubed. Now instead of negative 12x, plus 12x, and then no longer positive 7, but now negative or minus 7. When combining your like terms, there is only the one x cubed term here. So now I've got 8x cubed. Then again, there's only the one x squared term, so plus 15x squared. Now we do have two x terms to combine, 3x plus 12x, which is 15x. And then last, we do have negative 2 minus 7, which is negative 9. Then the third one, again, you are subtracting. So here we're subtracting our h of x here. So h of x again. So negative 8x cubed minus 12x plus 7. Then we are going to subtract f of x. Well, here's f of x. So f of x is 5x cubed plus 6x squared, because I'm writing in standard form, plus 12. Now make sure to distribute the negative or negative 1 to every term. So I'm going to rewrite this now as, sorry, let me scroll down here. I'm going to rewrite this as negative 8x cubed minus 12x plus 7, but now instead of positive 5x cubed, negative or minus 5x cubed. No longer plus 6x squared, but minus 6x squared. And then no longer plus 12, but now minus 12. Combine your like terms. I've got my 2x cubed terms here, negative 8 minus 5, negative 13x cubed. We only have our one x squared term, so negative or minus 6x squared. We also only have our one x term here, so negative 12x. Then last, we combine our constants. We have 7 minus 12, which is negative 5. Then question number 4 is asking which expression represents the perimeter of the figure. Well, here we have our quadrilateral, so we have our 4 sides here. So we have our 4-sided quadrilateral, and we're looking for the perimeter. So I'm going to pause the video here for you to try on your own, but what do you do to find perimeter of a figure? You add the sides, right? So think about if I'm adding up the sides, how are we going to solve this problem? So pause the video, try it, let's see what you get. Now let's see how you did. So adding up all the sides. So we are taking all of those 4 sides, right? So x, plus 2x squared minus 4x plus 6x minus 8 plus what other side am I missing? 3x plus 1. So now, just like before, combine all of your like terms. Notice how we only have the one x squared term here, so 2x squared. But we do have quite a bit of x terms. I've got x minus 4x plus 6x and plus 3. So here we have our 1x, so we have 1 minus 4 plus 6 plus 3. So here, 1 minus 4 is negative 3, plus 6 plus 3, and then 3 plus 3, or again, you could have put that all in the calculator, and you get 6x. That means I can already tell that my answer is C. Also notice, how do we get that negative 7? Negative 8 plus 1, negative 7. Then the last question, again, pause the video. You're looking for an error that was made in subtracting the two polynomials. Identify it and solve it correctly. So pause the video. Let's see if you identify the error and fix it. And let's see now if you identified the error and corrected it. I notice here that when I am subtracting, we need to distribute that negative or negative 1, but not just to the first term, right? To every term. So when I'm going to solve this, I'm going to go ahead and rewrite first. So I've got 6x cubed minus the 4x minus 5. Then we're going to combine with that, not just positive 3x cubed, right? But now negative 3x cubed. Then no longer negative 7x, right? But plus 7x. And then no longer plus 2, but now minus or negative 2. So right there, you should have noticed, and if you did, awesome job. The error was right here. What did they do? They distributed and got the negative 3x cubed, so they distributed to the first term. They left the negative 7x and the positive 2 here, just like the original. So they did not distribute to the entire trinomial or polynomial that was inside the parentheses. So now that I've fixed it over here on the right, I can now go through and continue solving. 6x cubed minus 3x cubed, we still get 3x cubed. But now you've got negative 4x, but plus 7x. So negative 4 plus 7 is now going to give you positive 3, so plus 3x. Then last, you have negative 5, but now minus 2. So negative 5 minus 2, negative 7.